Hello everyone, welcome back. In today's lecture, we are going to be getting into a concept in Java called encapsulation. So, first we need to think about how can we design our classes so that the data within them stay protected and are always in the correct state that we intended them to be. Now, the reason we need to think about this is because when you start working with your classes and your objects, it can get a little messy, especially when you're trying to work with data that's associated with those objects. So basically, what can happen is your object can actually break if their fields are exposed to another area of the code or another program. So if any part of your program can change, then your object's data could reach a point where it's invalid or it causes you issues in your code. So that is why you have to consider how your object interaction works. Now, what can happen if your fields or your object data are exposed? So you could have invalid data values, or your data does things that you weren't intending it to do, or some part of your code is broken, or you can't control whatever it was that needed to be controlled. And overall, these may seem like minor things, but it can be major depending on what your code is doing and what you need it to accomplish at the end of the day. So, just to kind of give you an idea of what I mean when I say these things. So, in this example, you see we have our student class again, pretty much the same one from the previous lecture, where we're looking at our name and our GPA. Now, we created an object called S, which is going to pretty much have the value of a new student object. And then we assign the fields name and GPA to the data values that they need. If you take a look at the GPA data value, s.gpa equals negative 42. In this case, there is not a way you can have a GPA that is a negative 42. That's just not a thing. But your code does not know that that's not a thing. So basically, this would be allowed. And this is what I mean when you could have invalid data points or inputs, and it could potentially mess up what you're trying to accomplish in your code. And in our case, a GPA would always be a 0 and between a 0 and a 4. So this is where your encapsulation would come into play. So encapsulation is pretty much just a principle that your class should hide its internal data and then also control it so that other code can interact with it appropriately. So the main goal of this is to ensure that the object's data states are intact, they are protected, the class can control how the data is used, and your objects are always going to be valid in the way that you need them to be. So there are various components that go into encapsulation. So we would be looking at our internal state, we'll look at information hiding, creating clear boundaries, having that controlled access, and then lastly our class invariants. And we will walk through each of these one by one. So first, getting into our internal state. This is basically stating that our fields belong to the object. So that means the data the class is responsible for keeping valid. So that would be the fields. Your fields have to remain in an internal state, meaning they need to stay valid for your class to run as expected. So the internal state typically deals with the field and making sure that it is valid. Now, information hiding actually just looks at making sure that the internal state is private so that the outside code cannot change it directly. So this is linking to that internal state portion. So It's basically making sure that your information stays hidden so it can't be changed. Then creating those clear boundaries. That's basically creating the separation between what happens when you implement the class and what other codes that can interact with it can do or interface. So there will be a time where you have various classes that work together, and there may be a time where you want one class to do something and the other class to not be able to do that. And that would be creating the boundaries of what each code can do or is allowed to do when it comes to that class. Controlled access is exactly what it means. We are trying to control access outside of the code. So this would be dealing with our public methods and making sure that they are safe and can be used the correct way by other programs. Then we have our class invariants. And these refer to the rules that the class has to enforce to stay in a valid state. So now that we've pretty much covered all those different areas of what encapsulation's aim is, pretty much we'll get into it in examples from here on. So what you need to know is Java is going to enforce encapsulation by controlling the class and making sure that the appropriate areas of the program or the code are visible when they need to be. So encapsulation is enforced using private fields, public methods, getters and setters, and access modifiers. Now, your private fields are used to hide the data. Your public methods are allowed to allow other code to use those methods, which define your safe interactions. Your getters and your setters are access control, but they also ensure that your data is valid. And you have your access modifiers, which is what allows your data or your methods to be visible to other areas. Now, first, let's get into your access modifiers. You've pretty much been seeing access modifiers up until this point, but not necessarily understanding what it was. But now we are to the point where we can discuss that and it should make sense. So, there are visibility keywords, which are referred to as your access modifiers, which pretty much define what other code can see. So you have private and you have public. So far, we've pretty much only used public, and as you can imagine, that just means that your other classes can call the method and constructors or those variables. It's basically meaning it's public information, it can be used by others. Whereas your private means that only the class can use that field or that method. It basically stays private to the class. So that is the difference between the two. Now, private is typically used for your class fields and any helper methods you have inside of your class. So again, only the class can access anything that is private in your code. So other than your private, you have your public, and that would be used for your constructors and your methods that can be used from outside of the class or by other classes that you may write. This is just creating a safe spot for your class to work without having to worry about it be impacted by those certain unsudden changes or invalid states. So this allows you to use the class freely but still protect it in a way. And this is commonly used with your getters and setters that we will cover in a few. So keeping your fields private protects the object's internal state and will prevent it from breaking. And this is why you need to remember that private typically plays a important role when you're working with your OOP or your classes and your objects. So private fields. This is pretty much making sure that no outside code can change your fields or your data values in your class. And that's just to help you prevent any invalid values or overriding it or changing the internal state. So, an example of that is by placing the private um, access modifier in front of your data type and follow it by your variable name. So in this case, we have private double GPA and private string name, which means it is only private and accessible to that class that it is in. Now, in the example of public, you can have public methods, which allow you to safely use these methods and other codes to interact with the object, but it still will enforce the class's rules. So, how you would do that is simply by placing public in front of the method to let the class know, hey, it's okay for others to use this specific method, but it's still protecting it to make sure that nothing is done improperly with these methods. Now, your private methods are just going to be the methods that can only be called inside of the class. So they're going to pretty much be used to like hide any internal steps that have to happen or any steps that other code shouldn't access directly. So here we have an example of both of those cases. If you see, our class is public, meaning that our class can be accessed by other code that we write. The only other thing we have public inside of this class is our one method that says public boolean is valid. That means this method can be used in other code to see if something is valid. And in this case, it's looking at a password. So it's just basically used to make sure that whatever passwords are used in other codes are valid. Now, the two that technically are private here are going to be what we would refer to as sort of a helper method, meaning that it's doing some sort of task inside of our class that we don't necessarily need to use in another case, but we need it to do or accomplish something in that class. And in this case, we have the two private methods that are has minimum length and has number. If you take a look at our isValid method, they are using those two helper methods or our two private methods, has minimum length and has number inside of it to do a action. So technically, other code does not need to see these two methods, but our class needs to see this method in order to do one of the public methods. So this is what I mean when your private methods are technically helper methods that don't need to be seen by other code. So getting to our getters and setters, these are what allow you controlled access to your different fields in your class. So your getters are going to be used to get or return or retrieve information from your class. Your setters are going to set or validate whatever data or changes are made before you update the field. And this is what allows your objects to stay valid and in a consistent state. So your getters and setters are going to be very, very important when it comes to OOP. Now your getter is going to return or get a value of a private field. So it's basically like a read-only access. It's just going to return the value to you so you can see what it is. And here we have an example of that. You see it is accessible because it's public, and it's pretty much saying we need to get the GPA, and the only thing that it does is return the GPA value to the user. With your setter, this is going to validate and update your private field, so it does give you writing access. And in this case, again, it is public, but you see we're using void here. We're passing in a data value, and it's basically going to check if that data value meets the certain control or validation, which in this case is an if statement that's going to see and make sure that the value that's passed in is between 0 and 4. And if it is, then it will set it. If it's not, then it would not set it. So this is showing you that it is validating and updating a private field if it meets a certain criteria. So overall, here's a good shot of a encapsulated class. So you see here we have our private fields at the top. So that's going to be our name and our GPA, which means they cannot be accessed, um, outside of the class. Then we have our constructor, which is public, and pretty much it's saying, hey, we're going to establish our class name and our GPA for this. We have a getter, which will then get or retrieve the name of whatever is placed into it. We have another method that is for our getter of our GPA. So we have a get name and a get GPA, both pretty much getting the name of the person and the GPA. And lastly, we have our setter, which is going to take in some information, make sure it's valid, and if it is valid, then it will set that to whatever the data value is. So that is kind of how encapsulation works. It's just making sure that your data is protected, it's seen by who it needs to be seen by, and it is accessed by who it needs to be accessed by. So to give you an idea of how you can use the encapsulated class, you pretty much can have outside code that can use the object, but it can't actually change the internal data of it. So an example of that is if we were to create like another class, create an object within that class, because again, remember, your classes are generally public, so the class can be accessed, which means the object can be accessed. So if you were to create a new object from a public class, you can work with it. And you can, again, use those methods. So get name, get GPA. You can update that data safely. So if you take a look at our last line of code there, it says it's going to set the GPA to 900. So technically, it would try to set up the GPA to be 900, but again, it would be rejected based on that validation that we did within our if statement and our method. And that's just showing you how encapsulation works. So even if a person were to do something that technically is not allowed, we have all our bases covered because we set up a validation inside of that setter that's going to prevent it from happening if somebody were to try to attempt it. So overall, that is covering encapsulation. It's basically telling you, hey, we need to make sure that our classes are run how we intended it to, that people can't change the data how we don't want them to, and it's basically placing a control over our classes and our objects as we're working through those. So we've covered our encapsulation, our access modifiers, and our getters and setters. And now that you know all of these components, we will tie them back to our classes and objects so that you can create safe classes and objects that you can work with within your Java code. So I will place this in a coding tutorial with our classes and objects so that you can get the full idea of all of the concepts that we have covered in the previous 2 lectures. So thank you for sticking around for another lecture, and I hope to see you in our coding tutorial for these topics.